Hello, I'm Ryan with High Desert Math Tutor, and today I'm going to show you how to divide rational expressions and overall just how to simplify rational expressions. So most of the time when you're dealing with rational functions, you want to be very cautious about first finding the domain of the function so that when you do come to your final steps of the problem of simplifying this, or say you're trying to actually, in this case, we're just simplifying this. We're not going to actually solve for any particular values of x, but you have to be careful to make sure you don't end up with extraneous solutions, which extraneous solutions are extra solutions that come from doing correct algebra. So in this instance, we're just simplifying this, but we will point out the domain along the way. So first, in finding the domain of this, we need to ask ourselves, what values of x are we not allowed to use in this overall expression? And the only thing we have to be careful with is dividing by 0. But here we have many situations where we could divide by 0. So for example, in this first rational expression, this is x squared minus 5x plus 6 divided by x squared minus 1. So here's a situation where we could actually divide by 0 potentially. Here we have x squared minus 2x minus 3 divided by x squared minus 3x plus 2. Here's another situation where if this was to become 0, we could divide by 0. And here's a really interesting third consideration. This whole thing is being divided by this whole thing. So usually we don't mind if a numerator of a rational function becomes 0. It's not usually a problem. But in this instance, since we're actually dividing by this entire thing over here, this numerator cannot be 0 either. So we need to first, before we really dive into simplifying this thing, it wouldn't hurt to actually find out what x values make this denominator become 0, this denominator becomes 0, and this numerator. So the way we do that is we factor everything in this expression essentially, and then solve for the values that make these pieces become 0. So we can throw down an equal sign. For this first expression over here, I'm going to put the fraction bar, set myself up for
exercise ring closed.
Yep, this is my exercise. Set myself up for factoring, and then we can ask, what do you multiply to get x squared? X and x. Since this is positive, both terms will have the same sign in the middle. Since this is negative, both are negative. And then you multiply 1 and 6. Oh, I'm sorry, that's not right. You're going to multiply 2 and 3 to get 6, and then 2 plus 3 equals 5. Here, if you know, this is the difference of squares, which gives us x plus 1, x minus 1. We have our division here. And now this numerator, we have x, x, this is minus. So one of these is positive, one is negative. So what multiplies up to 3 but adds up to negative 2? It'd be negative 3, positive 1. Here, x, x, this is positive, so these are going to have the same sign. Since this is negative in the middle, both of these are negative. What multiplies up to 2 adds up to 3? Negative 1 and negative 2. So we've factored this entire expression, and now we want to figure out what makes this denominator equal 0. So this denominator has been factored into x plus 1, x minus 1. So I'm going to do this work up in the top over here. So for this factor, x plus 1 equals 0 when x is equal to negative 1. Here, x minus 1 equals 0 when x is equal to positive 1. So these are two values that we need to be cautious with. So even though we said x is equal to 0, what we rather say is actually x plus 1 is not allowed to equal 0. So x is not allowed to be negative 1. X minus 1 is not allowed to be 0. So x is not allowed to be positive 1. But we have other pieces that we need to do similar work with. So let's take this denominator now. So we already see here that x minus 1 is not allowed to be 0, so that one's taken care of. But x minus 2 is another consideration. X minus 2 is also not allowed to be 0. So if we do a little algebra, we see x is not allowed to be 2. And finally, this numerator is not allowed to be 0. So x plus 1 is not allowed to be 0. And this is taken care of. But here, x minus 3 is not allowed to be 0. So you can see x is not allowed to be positive 3. So these 4 x values are restricted from our domain. Those are not in the domain of the function. So in other words, of all the x values that we might plug into this function, we're allowed to plug in any x value as long as it's not -1, +1, +2, or +3. So now that we're aware of that, we can just move forward in simplifying this. So whenever you have this division symbol, you keep the first fraction the same, change division to multiplication, then you take the reciprocal, or you flip the second fraction. So if we keep this one the same, we're going to have x minus 2, x minus 3 over x plus 1 times x minus 1. Division changes to multiplication. Now here, we have this one needs to flip over. So x minus 1, x minus 2 over x plus 1 times x minus 3. Now, here's where we all have some fun. We get to make this thing much smaller. So any factor that we have in common in the numerator and the denominator, they can cancel each other. So there's an x minus 3 here, and x minus 3 there, so those cancel each other. We have an x minus 1 and an x minus 1, those cancel each other. Now, notice there's an x minus 2, and there's another x minus 2 over here. But these are each in the numerators. We don't have x minus 2 in the denominator, so these x minus 2s, those do not cancel. Similarly, x plus 1, both of these are in the denominator. We don't have anything in the numerator, so those do not cancel either. So if we put this together, just a little bit more simply before our final steps, we can write this as x minus 2 times x minus 2, what's left over in the numerator, x plus 1 times x plus 1, what's left over in the denominator. And now, if we multiply this out, what we're going to get is x squared minus 4x plus 4 over x squared plus 2x plus 1. So this is the simplest form of this original expression. And even though we're not solving for an x value that makes this equal to a certain number like 5 or 0, it doesn't hurt anytime you're working with rational expressions to first find the domain so that you know which x values are off limits, which ones are restricted, and which you are actually allowed to use in your final answers when you are solving for x values that make this equal to a certain value.